Hello, welcome to The Extraordinaire, where we are committed to the relentless pursuit of excellence. If you love tech, you love learning new things, or you just want to scale up, make sure you subscribe to the channel so you don't miss any of our content. We are going to be going through Python standard library, and in this first episode, we'll go through a few of them. We'll continue in subsequent episodes. So let's hop into it. The first library we are going to be looking at is the operating system interface, which can be accessed via the OS module. Let's see some examples of that. So I'll create a new file here, say examples.py. Here I'll just import our OS module, and here I can now do some things with it. One of the things that we can do is return the current working directory. I can say print os.getcwd. This would give us the current working directory. So let's run this script. And we get the current working directory to be this. Another thing that we can do here is we could change the directory. We could also create a new directory. So let's try to do that. But first, we have to be careful while we are doing this, and I will show us why. So let's say we want to create this directory now. We'll say we want to change the directory. We'll say os dot, let me write print here, os dot change directory as chdir, and then I pass in /server/access logs. And if I run this, I get an error. And the reason why is because there is no such directory as /server/access log. As we can see here, the main directory, the root directory is /home, right? We don't have such a directory as /server. If we wanted to, we could go out to the root directory and create a new directory called server, but that's not what we want to do here. What we want to do here is we want this directory to be inside of our standard library directory. So we're going to take some steps to make it to be inside of our standard library directory. One of the things that we need to do is we have to now create the directory that we want to access. So we'll say server, and then we'll create another directory, new folder, we'll call it access logs. So in order for us to be able to change into this server access log directory, we have to remove this / here, so that Python can see that we are trying to access a directory inside our current directory. If we have this / here, Python will think we are trying to access a root directory, and it will try to do that, which, as we've already seen, is going to produce an error. So let's proceed. Now if we run this, we no longer get an error, we just get this none returned. But when we moved into that directory, we didn't do anything, so we won't notice any change. So let's go ahead and create a new directory when we change. So we'll do os.system make directory today. And if we execute this again, we see that today directory is added as a subdirectory under access logs. Now you have to be also careful when you are importing the OS module. Make sure you import it this way instead of doing something like import, or rather from OS import asterisk. Reason being that if you do it like this has some issues. If you do it like this, it's going to, the os.open function will shadow the built-in open function. which we don't want. Okay, so the os.open function will shadow the built-in open function. So we don't want to do it this way. Instead, we want to do it this first way. Use this. The built-in dir function and help functions are useful as interactive aids for working with large models like OS. So we could do something like this. If I say dir print dir OS, let me import it. If I execute this now, let's clear this first and execute, I get a list of functions that are functions and other names that are accessible via the OS module. Now, if you see, everything here is looking all jumbled up, right? So to make it appear cleanly, we could do something like this. Instead of printing it directly, we can say for item in dir OS print item, then we're going to give it a new line. Now if we execute this, we get each name and function printed on a separate line, which is cleaner and easier to read through. So we could also do print OS help OS, and if we do this, we get a help for the OS module, which basically documents the OS module and tells us what each module, each class, each function, each name is and what they do. So we can read through this to get a better understanding of how to use the functions that and other names that are available on the OS module. For daily file and directory management tasks, the shutil module provides a higher level interface that is easier to use. So let's see that example. Import shutil, and here we can say shutil.copy file data.db archive.db. What do you think is going to happen if we run this script? Before we do it, I want you to drop your answer in the comment. What do you think is going to happen if we run this script? Have you dropped your answers? Right, let's run it. We get an error. And why did we get an error? It's because we don't have a file called data.db in our current directory. So we have to first create this data.db before we can copy it. So let's go ahead and create a new file here. Data.db. Now if we come back and run this, it has copied this data.db to a new file called archive.db. We could also move files. Again, for us to be able to do that, we have to first create the directory that we want. So we'll go ahead and create a new directory here, call it build, and then inside that build we're going to create another one called executables. Now I want to move these executables to a new directory, so it will no longer be under build and there will be no such directory as executable. It will now be something else, which we are going to do now. So let's do that. shutil dot move build / executables, and we're going to change it to install directory. Also, make sure you don't leave this / here. You have to remove it so that Python knows that we are trying to access the directory in our current working directory. All right, now let's execute this, and we see that install directory is created and there is no longer any subdirectory under the build directory. The glob module provides a function for making file lists from directory wildcard searches. Let's see an example of that. So we import glob and we can say print glob dot glob asterisk.py, and if we run this, what do we get? We should get only one file, which is our examples.py file. So let's run it. Yes, we get examples.py. Now if we should do print glob, let me just copy this. What if we do this asterisk.data? What do we get? Can you guess? Lock in your answers. What do you think it is going to be? Asterisk.data, glob.glob, asterisk.data. What is it? Now it's going to be an empty list. Why? Because we don't have any file or anything called that ends with .data in our current directory. So if we run this, what do we get? We get an empty string. We get an empty list rather. Well, what if we do asterisk.db? What do we get? Think about it for a second. Asterisk.db. We should get archive.db and data.db because those are the only files that end with .db. So let's run this, and there we have it. The glob module makes it trivial for you to find files lists with this kind of wildcard searches. Common utility scripts often need to process command line arguments. These modules are stored in the sysmodule argv attributes as a list. So let's see an example. We're going to create a script here, say demo.py. Inside this script, we're going to import the sys module, and then we're going to print the sys.agrv. Now if we execute this demo.py script, what do we get? Demo.py, we're passing 1, 2, 3, and we get to see the arguments that were passed as the arguments for that script. The first value is the name of the script itself. From the second value, we get the arguments that were passed. The argparse module provides a more sophisticated mechanism to process command line arguments. So let's see an example of that. We'll create a new module or a new script, top.py, and in here we're going to import the argparse module. Then we're going to define our parser to be argparse dot argument parser, and here we're going to say prog is top and description is show top lines in each from each file. Save that. Then we're going to add some arguments here. So we say add argument file names nargs equal to plus and dot add arguments, add argument, we have dash l dash l, and the type is int, default is equal to 10. So these are like aliases for the arguments dash l and dash l, and file names are like aliases for the arguments in that you are going to be passing to the script. So now that we have our parser, we've added some arguments to the parser. We can now come out down here and say args equal to parser dot pass args, and we can now print the args. Great. Now if we run this script, python 3 top.py, and we pass in the lines to be equal to 5, and we say alpha.txt, beta.txt, the line would be assigned to the arg.line, and these files here will be assigned to the arg.file names. So let's execute this and see what. So we see that the file names, we have alpha and beta, and then the lines we have 5. The sys module also has attributes for standard input, standard output, and standard error. The latter, which is the standard error, is useful for emitting warnings and error messages to make them visible even when the standard out has been redirected. So let's see an example of that. Come back to our examples file here and comment these ones out. And here I'm going to import sys, and I'm going to write to the standard air, say warning, log file not found, starting a new one, the new line at the end here. And if we execute this, Python examples.py, we get the warning, log file not found, starting new one. Now notice that we didn't have to put print, we didn't have to put this in a print function. We didn't have to put this in a print function. Why? Because the sys standard air gives us access to the standard air stream, and so, and as such, we could just write directly to the stream without having to call print. The array module provides regular expression tools for advanced string processing. For complex matching and manipulation, regular expressions offer succinct, optimized solution. So let's see examples of that. We import the RE module, and we can come in here and print re.findAll. Can do R in front to mark it as a regular expression. BF A to Z asterisk. We can now put our string that we want to search on, which foot or hand fell fastest. So this should give us the strings that start with F, and if we execute this, we get foot, fell, and fastest. Let's duplicate that and do the second example. Here we have substring instead of find all. We're getting a substring. We have parentheses /b square bracket a to z plus close bracket /1. Again, the second parameter is /1 in a regular expression string, and the third parameter will be cat in the hat, okay, and print cat in the hat. Honestly, I don't know what this is supposed to do, but as we can see, it works based on the example. When only simple capabilities are needed, string methods are preferred because they are easier to read and debug. So let's say we have a mistake here. Mistakenly wrote T for 2 instead of T for 2, so we can replace 2 with 2. Now we should get the correct string if we execute this T for 2. We're going to stop here today for the Python standard library. We'll continue in the subsequent episodes. If you enjoyed the content, do like and subscribe and share with others, and I'll see you in the next one. Bye.